We talked about how to make input-output tables and consequently graph these lines on a coordinate plane. So let's talk about a little bit about what, once we put these on a graph, start describing a little bit, and then we can use this idea to sort of create equations, and we'll come up with another way of graphing lines instead of just having to generate an input-output table every time. So general idea here is we want to try to look at patterns that are being made and how they look when we put them across a graph. So let's go ahead. This is the beginning 8.4. This is all sort of going to be 8.4, 8.5. The textbook, again, since we're sort of moving away from the order of the textbook, going to kind of move through this idea sort of back and forth between chapter 8.5, 8.6. They all sort of go together. So let's take a look at this. All right, here's a line. And I didn't put the XY axis in there because I just wanted to take a look at this. And I want you to sort of jot down a couple of notes. Just pause the video and just describe this line. If you were trying to describe this line to someone who couldn't see it, okay, tell me, how would you describe it? What would you tell them? What are some things that you would say about this line to somebody who couldn't necessarily see it? Go ahead, pause the video and see if you can write some notes down. Okay. Well, bring those to class. I'm curious to see what some of you guys say. And we'll talk a little bit more about it in class, okay? So, let's move on. Okay, there's this thing that's called the parent line, all right? And what this really is it's this equation, y equals x, okay? And let's think about what this means. X means input, y is output. So basically what we're doing here is the output is equal to the input, right? The output here is going to be equal to whatever I put in. So I just get the same thing. It's when they're equal. So let's say you were going to generate an input-output table here. Okay, let's say we start with this. We'll start with this input -2, -1, 0, 1, and 2. Again, another way of saying this is called domain, but you don't really have to know that until next year. But we'll do -2, -1, 0, 1, and 2. And if my output is going to be equal to my input, then I'm going to end up with the same things, right? So when I put in -2. When I plug in -2 and I plug it in here, I get -2 out. If I plug in -1, I get -1 out. Okay, and so these points are going to lay across, or they're going to sort of, if I put them all in here like this, okay, they'll all sort of go there. And if I connect these dots, okay, I'm going to get a line that's going to go run through like this. Okay. This is the parent line. All other lines are going to be versions of this, okay? Some of them will move up and down. Some of them will move side to side. Not really side to side. All these lines really will just either go up and down, or they'll be steeper or flatter, okay? So let's take a look. Let's explore this idea a little bit more, okay? And of steeper and shallower, okay? So that's the idea of slope, okay? And the slope is the ratio of how much a line goes up or down compared to how much it goes side to side. Really, it's describing the steepness of a line, okay? We can say it's the steepness of a line, okay? How fast it's rising, or how slow it's going up, or that's really what it's describing, how steep it is, okay? And that's why you slope. If you think about slope, where do you hear slope? You know, think ski slope, okay? And it's you know, a really hard ski slope is one that goes down really fast, okay? You know, here in Chicago, Midwest, we don't really have a whole lot of ski slopes because it's very flat, okay? So M is the letter. Okay, M is the letter here. This right here, this is the letter we use for slope. So make sure you remember that. So M, and this is just sort of the shortcut we use. We talk about the rise over the run, okay? And really the way you find the rise is you look at the difference in the y coordinates, okay? You go from one point to the next and you look how much does it go up, and then we look at the difference in the x coordinates, right? How far side to side. Okay, and we'll explore more about this. Don't worry about this part so much right now, okay? This is going to be helpful. But I think what's going to happen is you start looking at slope, this will come later, okay? So this is the definition. This is what M is equal to. M stands for slope, and just remember that part. Okay, so let's move on. This is what we would call a positive slope, okay? So the reason why is because if as x goes up, right? If I'm starting here, as x increases, so does y, okay? As x goes up, right? If I move in a positive direction of x, I go in a positive direction for y. So it's going up, right? As you can think of this, the way I always look at this is money and this is time. As time goes on, I get more money, my bank account is going up, right? I get, time goes on, I get more money. Okay? This would be a positive slope. Here would be a negative slope, okay? This is as time goes on, my money goes down. So as x increases, right, as x goes up, y goes down. So this would be a negative slope, okay? And you could sort of conversely look at the other way. If x goes down, y goes up, right? So it's really one of the two are going down. In fact, let's go back here real quick and let's look at the positive slope. Remember what I said is as x goes up, y goes up. So let's flip it, and if x goes down, then y goes down. See how the signs, they're both going in the same direction, okay? Here they're going in opposite direction. So as x goes up, y goes down. Or as x goes down, y goes up. Now, a lot of times people will look at this. If you want to go down first and then over, that's fine. You just have to remember that the rise or the x or the y, how much we're going up and down, that is always the numerator of or that's the top part of the ratio of slope, okay? It doesn't really matter how you look at it, but the format in which you write it is definitely important. But again, this is sort of an introductory video, so let's look at another one. Here's a zero slope, okay? And so what you can say is as x goes in a positive or even a negative direction, right? If it goes in a positive direction, y doesn't change, right? So it's y is 0, okay? Or it does not rise, but it runs and it can run forever. And this is a zero slope. And you can think of this as flat, right? If something is rolling, right? Or if you're standing on this would be flat. It has no slope, okay? Like if you're trying to ski on this, you wouldn't go anywhere, okay? If you put a basketball and set it on here, it wouldn't roll. Whereas here, if you put it on here, it would roll, and you could say this would roll down, right? And this is kind of a negative slope. And here you'd have to, if it's going this way, it would have to roll up. Now it would roll down, but it would roll down backwards, right? So that's the idea. Or if you're climbing uphill. This one maybe looks like you're climbing downhill. This one looks like you don't have to climb at all. And then you have what's called an undefined slope, okay? And this is just straight up and down, right? If I were to put a basketball on here, it would just drop. It wouldn't even roll, okay? And really the reason this is undefined is because x doesn't move, x doesn't change, right? We don't go side to side, and it goes only up and down, okay? So an undefined slope. And we'll talk again more about this, what it looks like with the actual numbers tomorrow in class. All right, so you have the 4 of them. Let's go ahead and we'll we'll practice. So you tell me in your notes. Go ahead. Maybe draw a sketch of it. We'll draw a sketch of the line, and then you tell me which is it going to be A, B, C, or D. Is it going to be 0, negative, positive, or undefined? Well, good. I'm hoping you said D. D is the correct answer. It is undefined. All right, let's try another one. Is the slope here? Is it A, 0, B, negative, C, positive, or D, undefined? Well, hopefully you said it's positive, right? As x goes in the positive direction, right? This is going positive. Y goes in the positive direction. So they're both going in the same direction. They're both going up and up. Or you could say they're going down and down, or down and down, right? Both in the negative direction. So it would be a positive slope, okay, when they both go in the same direction. All right, how about this one? Good. Hopefully you said A, 0, has no slope. There's no slope here. And finally, the last one, by process of elimination, I hope you say that it's negative. Okay? Good. All right, well, let's take a look. Now let's actually find the slope of the line. So let's take the slope here. Let's find the actual numbers that go in this. So first tell me if you think this is going to be a positive or negative slope. Okay, hopefully you said it's going to be a positive slope, right? Because it's going it looks like it's going up, right? As x increases, so does y, okay? So they're both going in the same direction. So we know that's positive, and let's look at how it actually moves across this graph, okay? So looking at, we want to describe sort of the steepness, okay? Well, here's the parent. This is the parent one, right? Um, the parent line, okay? And what this one does is this is when y is equal to x, okay? So the blue one here, the blue one, we'll call this is the parent one. This is where y is equal to x, okay? Now I want you to tell me something about the purple line. As you look at the purple line, tell me something about it, okay? Think about what that looks like, and then write down something that you notice about it. Okay. Again, bring those class. I'm curious to see what you guys, some of the things you put. Hopefully one of the things you wrote is that it's steeper, okay? That it looks like it looks like it goes up faster, right? I mean, let's say if you were climbing this hill, this would be a harder hill to climb than this one, right? Because this is steeper, it rises faster, okay? So what I'm going to do here is I'm going to get rid of the, let's get rid of the parent function, line, okay? And erase that for now. And so let's look at this, and we'll talk about how much does it go up and down, okay? So let's see. We can say that it goes from here to here, right? If you look at from one point to the next, okay? From this point to this point. What it does is it's going to travel over here, right? It goes over 1, okay? And then from here, it's going to go up 2, okay? Well, if you remember in the beginning, we said that this is equal to the rise over the run, okay? Well, so how much does this thing go up and down, right? We said rise over run. So what we can do is we can say, all right, let's look at the ratio. When we look at this line, how much does it go up compared to how much it goes over? Okay, and that's going to describe what it does from each point to the next. Okay, so let's say from our rise here, it goes up 2. Okay, so we go up 2 over. Okay, and then we're going to compare it to my ratio, or compare it to how much it goes side to side. Let's go over 1. So for every 1 that it goes over, it goes up 2. Okay, well let's see if it keeps working. Okay, so from here, if I go, it follows the same idea. Okay, so it goes over 1 and up 2, and you could do it in any order as long as you remember that this is up and down and this is right and left. So it says go right 1 and up 2, right? So let's see, does it work? Let's see, if I go over 1, I'm going to go up 2. Okay. And if you simplify that, that's going to equal a positive 2, which should make sense, right? It's a positive slope. It goes up in the positive direction. Okay, and it also it follows through. Let's say I start at this point, and I want to know from this point all the way over to this point. What does it do? Okay, well let's see. I'm going to see. I'd have to travel over 3, right? Over 3. Well, if we look at our slope, right, what this is saying is you go up 2 for every 1 that you go over, right? So it's like as this goes up 1, this goes up 2. So if this goes over 3, then it should go up how much? Hopefully you said 6, right? Because it's going to go up twice as high as it goes over. So we went right 3. Okay, so let's see if we go up 6. So we'd go up 2, 3, 4, 5, 6. Okay, and we went up 6. And in fact, let's go ahead. Let's see. Let's color that line red so we can. No, it just did all of them. Okay. Well, let's try it again. Let me try to get this one red so you can see it a little bit better. There you go. Okay, so it goes over 3. Okay, and then it goes up 6. Okay, and that still follows that idea of a 2 to 1 ratio. So the slope in this one would be 2 to 1 goes up 2 for every 1 that it goes to the right. Okay, what I want you to do in this one is I want you to graph these 2 points. Okay, and then I want you to come to class and I want you to tell me what the slope is for this one. Okay, I want you to tell me both if it's positive, negative, 0, or undefined. And then I want you to also give me the actual number that it is. Okay, so go ahead and do that, and good luck. bring those notes, bring any questions you might have, and we'll discuss more in class tomorrow.